learners, I am Dr. Ganga, Associate Professor, Department of Biomedical Engineering, Hindustan College of Engineering and Technology. In this video, we will learn about some standard signals of signals and system. First, we should know what is standard test signal. The standard signals are often used in control systems, signal processing, communication, and various engineering applications. These are predefined signals with known characteristics. To clarify standard test signal, their uses and application in the control systems. What is signal? A signal is a physical quantity or a function of one or more independent variable such as time and space. It contains or conveys some information. It carries some information. That's it. There are many signals in this world which change with respect to time and space. The standard test signals are the signals which are used to estimate the performance and characteristics of the system by analyzing the responses of these signals. These signals are applied one by one as input to the system to determine different responses of the system in different cases, and then we estimate different characteristics of the system such as stability, linearity, transient response and frequency response by analyzing different responses, or we can say output of the system. In terms of mathematical representations of signals, these signals are used to represent complex signals. This is a general block diagram of simple control system. Whenever we can give any input to the system, that produces a particular output to respond to the given input. The standard test signal is mainly classified into step signal, ramp signal, impulse signal, and parabolic signal. The last video we learned about unit step signal. In this video, we will see ramp signal. A ramp signal is one of the standard test signal. It is an increasing function which increases linearity with time. A ramp signal exists only for positive values and 0 for negative values. It is denoted by R of t because the R is mentioned as a ramp. Mathematically, R of t will be t for t greater than equal to 0, that is for positive values of t, and will be 0 for t is less than 0, that is negative values of t. The ramp signal is used to analyze system response to linearly changing inputs. It is also known as velocity type input. The ramp input is defined by its slope. There are two types of ramp signal. One is continuous ramp signal, another one is discrete ramp signal. Continuous ramp signal can be defined as the following expression, that is R of t is equal to A into t. Here the t value is greater than 0. Suppose the t value is less than 0 means the R of t value is equal to 0. The above expression implies that it is a continuous ramp signal of slope A. For A is equal to 1, this step signal is called unit ramp signal of slope 1. Continuous unit ramp step signal can be defined as the following expression, that is R of t is equal to t for t is greater than equal to 0. If t is less than 0 means the value is equal to 0. This is a graphical representation of ramp signal. This is R of t is equal to A into t. Here R of t is equal to t. This is a value of ramp signal, unit ramp signal. Discrete ramp signal can be defined as the following expression, that is R of n is equal to A into n. Here n value is equal to 0. Suppose the n value is less than 0 means the R of n value is equal to 0. Here n means integer. Thus the above expression, it implies that the ramp signal with slope A. Here A value is equal to 1 means the step signal is called a discrete unit ramp signal with slope 1. A discrete unit ramp signal can be defined as the following expression, that is R of n is equal to n for n is greater than 0. If n value is equal to 0 means the R of n value is equal to 0. Here also the n is integer. This is a discrete time ramp and unit ramp signal. Here discrete time ramp signal, this is a unit ramp signal, that is R of n is equal to A into n. Here R of n is equal to n. The application of RAM signals or control system analysis, signal processing and filtering, and motion control and robotics. In control system analysis, the RAM signals are to study the response of systems to gradual changes in input. By applying RAM signal as input to control systems, we can analyze the system's response to linearly changing inputs. In signal processing and filtering, the RAM signals are used in signal processing applications such as filtering and trend analysis. By convolving signals with RAM functions, we can perform linear trend removal or filtering to extract trends from noisy or fluctuating data. Next one is a motion control and robotics. In RAM signals can be used in motion control system and robotics. RAM signals are utilized to command smooth and controlled movement of actuators and robotic manipulators. Next, I will explain some advantages of RAM signal, that is velocity profile representation. It means the RAM signals are particularly useful for representing velocity profile in modern control systems. Next one is a linear input analysis. RAM signals are used to analyze system responses to linearly changing inputs. This allows us to determine how system will react to gradual changes. Next one is a simplified modeling. The RAM signal offer a straightforward modeling approach for systems that exhibit linear response characteristics. Their simplicity makes them easy to implement and analyze mathematically. Next one, advantages, versatility in applications. That is, RAM signal can be used in different applications across various engineering domains, including motion control, robotics, signal processing, and industrial automations. This kind of RAM signal having some disadvantages also. The first one is a infinite energy. The RAM signals have unbounded amplitude over time, leading to infinite energy. This impractically arises from the continuous increase or decrease in amplitude, which results in unbounded energy accumulation over time, making it challenges to generate or sustain in real world system. Next one is the unrealistic modeling. The infinite energy characteristics of RAM signal makes them unrealistic for modeling physical phenomena in the real world. Most physical systems operate within finite energy constraints, and the concept of infinite energy violates the fundamental principles of energy conservation and system stability. Next, one important disadvantage of RAM signal is complex analysis. Analyzing the behavior of systems subjected to RAM signals can be complex due to their unbounded nature. Mathematical analysis of systems with infinite energy inputs often involve specifically techniques that consideration increasing the complexity of system modeling, analysis, and design. Next one is a impulse signal. Impulse signal is one of the standard test signal. It is also known as a Dirac delta function. An impulse signal exists only at 0. The magnitude of an impulse signal is infinite. It is denoted by del of t. The mathematical